Yeah, I'm good.
Oh, I asked if you're dead, but fine.
Oh, no, I'm still alive.
All right, I'm not. Well, I am, unfortunately. I wish it would kill me already. Let's see. Pascal's triangle. So basically, binomial expansion is a fast way of expanding brackets with two things in them. So, like a bracket like 1 plus 3x or something that's got two things in it. If you had to do that to the power of 7, you could do 7 brackets and take a very long time to do it. Or you can find some quick ways. This
Hmm.
triangle shape, man called Pascal discovered this way back in the day. A plus b to the power of 0, 1, 2, 3, 4. And you notice you get these coefficients. And it's always the two above being added together. So 1 plus 1, 2. Here you've got 1 plus 3 making 4, 3 plus 3 making 6, and this would go forever. So these two here, the next coefficient here would be 10, and so on. And
Yeah.
you can use that. But don't worry, your calculator stores this using Pascal's triangle. Don't bother. I'll give you the quick way. Find all this. We'll come back to this using the quick way. They will show you in a second. Hence or otherwise, write the expansion of this. I'll come back to this. Wow. I'll come back to this. Is that the same thing twice? Or did I just press back by accident? I pressed back by accident. Wow, there's lots of this stuff. Okay, Pascal's triangle. Okay, factorial notation. So this is the just use your calculator method. You're never going to use Pascal's triangle for that stuff. Factorial notation. Fancy stuff. Do you know what this means? 5 factorial.
No.
Okay, that means 5 times 4 times 3 times 2 times 1. I'm going to try GCSE calculator for a change. Do I have this one? 5. Does this have factorial? An exclamation mark somewhere. There we go. Exclamation mark. Shift. And then that one. And that gives you the answer, 120. Okay.
Yeah.
This thing, 5C2. 5 shift division sign for the C.
Yeah.
And then 2, 5 choose 2. I hear the kids say, I don't know what the C stands for, is 10. Where does that come from? That comes from 5 factorial divided by 2 factorial. Wait, is that right? 10. That would be 60, would it not? Oh, no. That's what I'm forgetting. 2 plus 3 makes 5. And so it is 5 factorial, I was right the long way, times 3 factorial. There we go. So 2 plus 3 makes 5. And so the bit on the top is 5 times 4 times 3 times 2 times 1. And then the bit on the bottom is 2 times 1 times 3 times 2 times 1. If you do some cancelling, so first of all, times 1 won't do anything. We've got 2 and 2. We've got 3 and 3. And I suppose, so 20 over 2, or you can cancel like that. And that's where the 10 comes from.
Yeah.
Pascal's triangle, can't be bothered. Weird stuff. That's 9, choose 5. Sure. You're not going to use it though. Let us see. Okay, let's do these. These look good. Let's try these. Please, can you move it down? That's what you're going to say. There we go.
Thank you.
You're welcome, and you're very polite. Okay. Let's try this. Oh, what is the value of P? What is the value of Q?
Oh. 14.
Yep.
And the other way around, 22.
22, and they are all the same. So if you've ever wondered what a 1-mark A-level question looks like, that's what it looks like. 14, 22, etc. What is this malarkey? Show that this is that. Oh, is this actually an exam question? Okay, hang on. Factorial notation, yes. So this n choose r, or nr sometimes written, looks like a vector, not a vector. N is on the top, and then r is on the bottom with n minus r, and it's all factorials. Okay. And so the application of that was 25 is on the top, 11 is on the bottom, and 25 minus 11. And they're all factorial. So now we have to do this algebraically. Try that. I'm just going to turn this light up a bit.
So k plus 2 is equal to the top of the numerator. Is it?
Nope. This is very unusual. I think, you know the way this is factorial stuff. So it was like 5 times 4 times 3. I think that the top would be k plus 2 is the first one. Then the second one is basically k plus 2 take away 1. What is that?
K plus 1.
And keep going.
K.
Yes. And I think it would stop there. Then how about the bottom?
K.
Yeah. And what else? So the bottom was like, the top was 25, bottom was 11,
Yeah.
and so it would be 25 minus 11 as the other one.
Plus times 2.
I believe it would be k plus 2 minus k. What is k plus 2 minus k?
2.
Yeah. I'm just gonna. Okay. Well, it's a show that question, so we have to kind of show it, I suppose.
Fair enough.
And what happens there? Or what can we do?
Cancel the k.
Yes. And then we get what we were supposed to get.
Yeah.
Kind of makes sense, I suppose. How do we do question B?
So you set that equal to 36.
Yep.
And then would you times the top by 2 and 36 by 2 to get rid of the fraction?
Mm-hmm.
So then if you times the top by 2, do you just put 2 in front of the whole thing?
The left one or the right one?
Both?
Are you asking me how to times 36 by 2?
No, on the left side, yeah.
Left
But
side.
like, would you put it of both of the brackets?
You could. So if you put that times 2, what would happen there?
You would expand it so like 2k plus 4.
Okay, it's also divided by 2.
Oh, it just cancels.
Yep.
Okay, never mind.
Both ways would work. It's just quicker to cancel first.
Yeah. That the bottom part is equal to 72. So then would we expand it to get a quadratic?
Mm-hmm.
So k squared plus 2k
Go on, you
plus
expand it.
k plus 2. So k squared plus 3k. Oh, and then we have to move. So the plus 2, so we do 2 minus 72. So we have k squared plus 3k minus 70 equals 0.
Mm-hmm.
I think.
Mm-hmm.
I got x equals 7 or x equals minus 10. So
Question
does it have to be... Do we have to choose a specific value?
Yes. Question C kind of incorporates that.
Maybe it's something that like it can't be negative.
Why can't it be negative?
Because it gives a positive. 36 is positive.
It would give a positive. Both of these numbers will give 36 into our quadratic. I think it has something to do with this choose business. Yeah, you can't choose a negative number or something. K is a positive integer which is greater than 0. That's not very... Alright, K has to be positive. That's the answer they'll accept. I'm happy with that. Any questions there?
No.
I suppose it has something to do with that Pascal's triangle. You can't have a negative thing. Factorial notation. What do you give yourself?
I don't know, half.
So these questions are weird, but my conscience is clear. I've taught you the thing I'm supposed to teach you. Now we are about to do the normal stuff. Classic. Okay. Let me go back. Okay, this stuff.
Yeah.
So, I promised we would have a quick way of expanding brackets using Pascal's triangle. Let's see, Pascal's triangle. This one here, let's say. So that's to the power of 4, and that's 0, 1, 2. So that we always start from 0. That would be 1, that would be 2, 3, 4. Put into your calculator, so the power, 4, choose 2.
6.
Yes. And coefficient here is?
6.
Yes. And so that's how this works. So the power was 4. That's where the 4 comes from. Choose 2, because they always start from 0. And you can see how anything choose 0 is 1. Anything choose itself is also 1. And then I think anything choose 1 would be the original. Okay, we will use this to our advantage. We have to expand this bracket, and if you're anything like me, you are profoundly, profoundly lazy. This is to the power of 3. So we're going to have 3 brackets and go down the line like that, etc. This first one will be 3 choose 0, then 3 choose 1, 3 choose 2, and finally 3 choose itself, and that's where we stop. 3 choose 3. Second is the first thing, so x, 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 and that is going to be the power of 0, 1, 2, 3. Is that the way it goes, or is it the other way around? Hang on, if you were to expand this bracket, I think it would count down first. Yes, so you'd always start with x cubed. If we were to expand this bracket, we would get x cubed. So other way around. So this one is 3, 2, 1, 0, and it's the other bracket then that counts up. So that's 3, 2, 1, 0, and then the other one is 0, 1, 2, 3, and in the other bracket is 2y. 2y. And you work these out. So what is, okay, so the way we have to work it is, let me just do this the easy way. There we go. I'll save this somewhere. Okay. Our bracket can't do anything to do with algebra, so we just don't have any x. So
we
three.
skip it.
Sorry?
Do we just skip it?
We just don't put it into the calculator, but we just kind of know ourselves what it'll have to be. That part we have to figure out. Oh, sorry, x, you just put the coefficient of x. So in this case, we'll just do 1.
Oh. Okay.
And we cannot do 2, we can't do y, so we will do 2, just the coefficient of y. That one is to the power of 0, and x is to the power of 3. What do you get for that one? Ooh, I messed this up.
Oh. I got 1.
So first one is 1, and so now try, sorry, so the first one, you see this, we had like x cubed in there?
Yeah.
So that's going to be 1x cubed, or just 1, plus, what is this next one? So the 3 choose 0 becomes 3 choose 1, etc.
I got 6.
Okay, so 6, 6 x to the what?
Squared.
Yep.
And then for the next one, I got 12.
12.
And the last one, I got 8.
And what is x to the power of 0?
1.
Yep. What is x to the power of 1?
Just x.
Yes. And so this one here, the 12, has an x. So x cubed plus 6x squared plus 12x plus 8.
What about the y's?
Yeah, we forgot those y's, didn't we? Wait, or did we? Yeah, so what about the y's then?
do there is no y in the first one, I think.
Mm-hmm.
And in the second one, there's just one. And then the y squared.
Mm-hmm.
And then y cubed.
I hope so. X cubed plus 6x squared y plus 12x y squared plus 8y cubed. Bingo. It's a good thing you're here. Let's see. Let us now try that for question B.
Okay, so we do, is it 4 choose 0
Mm-hmm.
times 2x to the power of 4?
Yep.
And then times minus 5 to 0.
Mm-hmm.
Okay, then which is equal to 16
Okay.
x to the power of 4, I think.
Yep.
And then the next row is 4 choose 1, then 2 x to the power of 3, I think.
Mm-hmm.
And minus 5 to the power of 1.
And so what I'd recommend is that you fill all these in first.
Okay. Choose 2. I think I did it.
Okay. So what was it going down? First one?
The 4 choose 3 and then 4 choose 4, and then for the row of x's the power goes down by 1 and the minus 5 it goes up by 1 each time.
Yeah. And it's just because you can easily kind of get lost in the middle and accidentally do something. Okay, go for it.
For the 4 choose 1 row I got minus 160.
Well done.
And that's x cubed. And then we have 4 choose 2, 2x. Then I got 600x squared.
Okay.
Then 1000 x.
Something's not right.
Yeah, I retyped in the calculator and I didn't do minus 5, I did it as positive. So wait, let me just do that.
So you can just edit them each time.
Yeah, it's because one time I cleared it by accident and then when I typed in I did it wrong, I think.
Okay.
So wait, the 1000 is minus 1000. And then okay. And the last one I got 625. Yeah.
625. Okay. 16x to the 4 minus 160 x to the 3 600 x squared minus 1000x plus 625. Any questions there?
No.
Okay. I'm going to show you something. You can use it, you cannot. I went to calculator table f of x, for choose x. We cannot put in this x, so I just leave that as 2 to the power of 4 minus x, because it's going to be going down by 1 each time. And then the other bracket is minus 5 also to the power of x. So you'll notice, like, this is 4 choose 0, so this is minus 5 to the power of 0. 4 choose 1, minus 5 to the power of 1. So those are the same. And then the other one starts at 4 and it's going down by x each time. So 4 minus 0, 4 minus 1, 4 minus 2, etc. Press equals. So I believe we are starting at 0 and stopping at 4. Press equals. Hey, is that totally wrong? Oh, I forgot all my powers. That's why. No, I didn't. Hang on. What did I get wrong here? That is 4 choose 0. That is 2 to the power of 4. And that is minus 5. Oh, because that is not to the power of. To the power of x. 16 minus 160, 600 minus 1000, and 625. So nobody does it this way, but I just thought I'd show it to you. Yeah, so 4 choose x, and then the other one is to the power of 4 minus x, and that one is the power of x. Grand, you have to use that. Nobody uses that. Okay, let's see. Would you be confident with these exam questions? You think you'd know how to do these?
Yeah, I'm just confused by the second part.
And why it's only 1 mark?
Yeah.
Using your answer to part B for this one, what would be the expansion of 2x plus 5 to the 4?
Would the signs all be opposite the whole way?
So if you were expanding brackets and they had all pluses in them, would every second...
So there'll be no negative.
Yeah, and so what would be the expansion for this?
The same, but without the negatives, everything positive.
Yes. So this one, if you had the expansion for A, how would you do B?
You would do negatives for when it's like cubed and stuff like that.
Yes, when the power of that one is an odd number. So 1, 3, 5.
Yeah.
Yes. And there we go. Every second one is negative. Other than that, it's just kind of time consuming. Let's see. This one. How do we do part B for this one?
But X isn't K.
Say it again, sorry.
X is different from K.
So what could you do?
I don't know.
Let me see if I can quickly. 1 sec. I just want to save that stuff. And that. Whoops. And if I press up and that. Okay, that stuff is saved. Let's move it over to there or something. 4 plus k to the 3. Let's see, so that's going to be bracket 4 choose x.
How come you can write the x there, but you can't write it in the next bracket?
So I'm using x as just a variable for a number. So just that's like starts at, so it's just going to sub into that x, but not our other one. Then what was it again? No. Sorry, this is 3 choose x. 3 is the power. Then it is 1 bracket is 4, and this is to the power of 3 minus x. And then the second bracket is 1k, so I'll use 1, and that's to the power of x. So I'm just trying to speed it up a bit. That's from 0 to 3. So we get, these are our coefficients. And so what will be the values of k for each of these?
First one is k cubed, and then and then k squared, and then k, and then the last one is just it doesn't have k.
For this one, the k came second.
Oh, so the opposite way around.
So I think the opposite way around. So I think this one at the end would be cubed.
Yeah. Okay.
Okay, so let me just check. 64. Yeah.
Mm-hmm.
And then, yes. Any idea how you could use that to do part B?
Yeah, but we don't have x.
In terms of k. Sorry, in terms of x. So x will be in your answer. You don't need to know what number x is.
I'm confused.
You know how, if you kind of spot the difference, k equals x squared minus x?
Yeah.
Like these two are identical to each other. Substitution.
So we sub in that into the whole thing.
Yep. What would you get?
Or do you have to expand them?
Nope.
Why?
I don't know. Because it's a 3 marker. We'll expand it if we have to. What would it be if you didn't expand it?
48 bracket x squared minus x.
Yeah. So starting from the start.
64 doesn't have a k.
So it's just 64?
Yeah, and then 48 brackets x squared minus x, and then plus 12 brackets x squared minus x brackets squared, plus brackets x squared minus x brackets cubed.
X squared minus x cubed. That's full marks. Come on. They didn't ask for simplest form. Okay, they actually expanded it and they got x to the 6 and stuff. There you go. Do you want to go through expanding that whole thing?
Maybe the last one.
The cubed one?
Yeah.
Okay, how would you expand x squared minus x cubed?
Write it out 3 times.
I'll let you try that. If only I had just taught you a quick way to expand brackets.
So 3 choose. X. And then
What's the first one?
cube. Oh, x squared. minus x, and then to the power of 0. Oh, the x squared is to the power of 3.
Mm-hmm.
And now 3 choose 1, brackets x squared to the power of 2, minus x to the power of 1. And then 3 choose 2, x squared to the power of 1, and then minus x to the power of 2. And then 3 choose 3, x squared to the power of 0, and then minus x to the power of 3. So, oh no. First one, I got 1 x.
Okay. So that'll be 1, and it'll be x to the what?
Do you have to do x squared cubed?
Mm-hmm.
So x to the power of 5.
You've forgotten your GCSE.
Oh, 6.
Yep.
And then the next one, I got minus 3 x to the power of 4. And the next one, I got positive 3 x squared.
Mm-hmm.
And then minus 1.
Yeah. Hold on though. Let's go back to this x to the 4. We also have to times it by the x in the other bracket.
Yeah. I have my tutor.
Huh?
I have my tutor. Now, thank you.
So you had x to the 4, but it's also times this x here.
Times minus x, so minus.
So you've got the coefficient, minus 3.
So does it become positive?
No, you've already got the coefficient.
Oh.
And so we just need to figure out what the power of x is.
Mm. 5.
Yep.
Oh, yeah, that makes sense. And then the next one's 3.
So
I mean 4.
yeah.
And then x squared. No, just x is 3.
X to the 3. Okay. And so we would incorporate that into this one. So that would be like x to the 6 minus 3 x to the 5 plus 3 x to the 4 and then minus x to the 3, I think it was. And you would expand all of this stuff and fully simplify. And you should get the answer that they got.
Mm-hmm.
Is it worth doing, or you think you're good?
Mm-hmm. It's okay.
I think that's homework. Yeah, so this is the kind of the stuff that's like expanding a squared bracket. You'd probably just write 2 brackets, something like that.
Mm-hmm.
But once it's like to the 3 bigger,
Yeah.
it's better to go about it this way. Let's see. Find the values of A, B, and C. Is this worth doing?
They're the coefficients.
Yep.
Why is there like 3 lines instead of an equals? Oh, it means the same as.
Identical. Yep.
Okay. Wait. So you just expand it, and then the coefficients they're equal to the letters.
Mm-hmm.
So, wait, are we actually doing it?
Is it necessary to do it, or you think it'd be okay?
I think it'd be okay.
Yeah. So for the first one, they just did 13 choose 0, 2 to the power of 13, and minus x to the 0, and just did they just did the first 3. And
So you would only need to go to 13, choose 3.
Yeah. 13 choose 2, because we start from 0.
Okay, yeah.
Yeah. And so that's what they did. So they write it in a different notation. They write it as 13 1 instead of 13 choose 1.
Like a vector.
Yeah. But it's looks like a vector, not a vector. And calculator uses the C, so I use the C.
Mm-hmm.
I think that's the same question twice. Hold on. Pink pen. Duplicate. Okay, so this is the type of stuff I wanted to get to. How about this one? Hold on, before we do this, I just want to see if there's a simpler one. This one, okay, so they kind of have a trade-off. No, there's no simpler one. Okay, how about this?
So we have to expand it first.
Yeah. Or the coefficient of x squared. Could you just find the coefficient of x squared? So you don't have to do the whole thing.
So it would be, because it's on the right side, it starts to the power of 0, then 1, and then 2. So it would be 3 choose 2, and then 2 to the power of, it starts at 3, 2 to the power of 1, and then minus c to the power of 2.
And I would write in minus cx, and just be aware, because your calculator can't process c either.
Mm-hmm.
These 2 powers always have to add up to this one. So that's another way you can do it.
3 choose 2. And then 2 to the power of 1. That gives us 6. And then we do 6 times c squared x squared.
Well done.
And then, so the coefficient of x squared is 6c squared.
Well done.
Which is equal to 294, I think. Is it?
Yep.
Okay, so then you just rearrange that. So you do 294 divided by 6. So then we get c squared equals 49. So c equals plus or minus 7.
looks good to me. Plus or minus 7. Yes. And so in this case, this is kind of common stuff. If I just go back for the exam question, they don't want you to expand 13 or 14 different things. They'll just say, give me the first 3, and basically you've got the idea. They usually never go any higher than x cubed, I don't think. Or the other way they'll do it is they'll just pick one somewhere in the middle, and you'll do it that way. And so this bracket would be 2 plus or minus 7 x cubed. Yeah. Great. Any questions about that?
No.
But the answer is plus or minus 7. That's what we got. Exam question. Classic. It's easier than the one we just did because there's no negative. I think you'll be fine. I just don't want to give you... Oh, they get difficult. Okay, hang on. That's question 7, but this is question 4. I should have put 4 first. This has a fraction. Yeah, this looks like a good one. Let's try this one.
So is to the power of p.
How do we do this?
How are you supposed to do that?
So that would be what? For the coefficient of x, what would be the brackets for that?
So it's the right hand side, so that means that it starts with the power of 0 and it goes up.
Mm-hmm.
And we want it to be the power of 1. Mm-hmm. So p choose 1. And then 1 to the power of like p minus 1.
Mm-hmm.
And then minus 3 over 2x to the power of 1. So then expand that.
That's not possible.
True.
Minus 24. So that will give us a thing with minus 24. So let's just take out... So that would be like equal to minus 24x.
Mm-hmm.
So I'm just going to calculator that. So just get rid of that x. I'm sure there's many clever ways. Hang on. Equals minus 24. I'm sure there's many clever ways. I'm just going to put that into the calculator solver and say my prayers. So I can't do p, so I use x for the unknown. So like x, choose 1. And then 1 to the power of... What can I do
X there? Minus 1.
Here's hoping.
Wait, do you know if it's actually going to work?
I never know. Minus 3 over 2 to the power of 1. Do you remember how to do equals?
Solve somewhere.
Alpha calc red equal sign. Minus 24, and then it is shift calc for solve. So you choose an initial value. I always go with lucky number 7. I'm going to need it more than ever today. And then you press equals twice. Tell me if it works for you.
No.
Worked for me.
Mine says math error.
Press left.
Yeah.
Is there some way that yours is different from mine? X choose 1. 1 to the x minus 1. And then minus 0 to So equals minus 24. Did you do equals minus 24?
Yeah.
Shift.
I think I did it the same. Yeah.
So shift calc for solve and put in some initial value for x. So you could use 7, you could use 3. Just pick some.
I'm just going to redo it quickly.
Okay.
Wait, how do you do how do you get the equals again?
Alpha calc red equals there.
Yeah. And then
So then it is shift.
I don't know why it just says error.
Hold on, press left.
Yeah.
I know what you're doing. You're pressing equals down here and you're getting an error. You press shift calc for solve.
Yeah.
And then you pick some initial value. I'll pick 799 and then you press equals twice.
I got 16.
Yeah. And the 0 underneath it just means it's exactly 16.
Okay.
Answer is 16. Answer is 16. So they did it some nerd way. Let's see this. So they did it using first principles, using that Pascal's triangle thing. So p minus 1, p minus 2. The coefficient of the x1. Yeah. How would you do part B?
Sub P, so 16 choose 2, and then brackets 1 to the power of 14,
Mm-hmm.
and then minus 3 over 2x to the power of 2, and then yeah.
And actually they just asked for coefficients, so we don't even need to have the x. And then that would just go in the calculator. And you should get 270. Maybe I just better, just to make sure, because I've taught you this method and they're using some Pascal's triangle nonsense. This method that we're using is absolutely the method.
Good. I got 270.
Yeah, so this is absolutely the method. They're using this method for Pascal's triangle, so like kind of where this comes from. It's like differentiation by first principles, but you're never going to use that. You only ever use normal differentiation. If you go to binomial expansion, suddenly there's no more Pascal's triangle stuff. It's just 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4. And so you would never do that. You can see what there, when find the first 4 terms. So that would be 10 choose 0, 10 choose 1, 10 choose 2, 10 choose 3, and then you would stop. Same with this one. So they don't ask you to do all 11 because it starts from 0, so I think there'd be 11. You only need to do those. Find the first 3 terms, find the first 4 terms. So because I taught you the normal method from the start, then all these are exactly the same as what you've done. Yeah, so first 3 coefficients, because you're using the same method, there is an extra little trick though. We would have to do it some other time, I think. Oh, there's no
Okay.
extra. There's no extra little method. I thought there might be, but there isn't. Yes. Let me just check. There has to be a section after this. Come on, binomial expansion. Solving binomial problems. Yeah, this is the thing. So the next section is when you've got to do it times a different bracket. And so that's got its own little thing. Binomial expansion, what do you give yourself?
Half.
Chicken does man a day. I bet you'd be grand with them. So, any topic in particular you want to do next time? We can do more binomial.
Not at the moment, but I'll let you know because I probably will be.
Okay. Any questions for me in general?
No.
And maybe, yeah. So, you get those emails that I send to you with the links and stuff?
Yeah.
Okay. Because I made something that I can be proud of. Let me see. captainsloanmaths.co.uk. Just made this for all you kids who are stuck at home. So this is I just put them together. So the kind of public videos that I have of other jackanapes, you can see those. So let's say A level pure year 1. There we go. Chapter 8 binomial expansion. So you can see Connell how he expands. So he's doing these same questions as you.
Yeah.
Although this was back in February of 2019, so I'm using a worse lesson. There you go. Yes, captainsloanmaths.co.uk. Any questions for me in general?
No.
All right, well done, Keelan. You did great, and look forward to chatting again next time.
Thank you.
Have
Yeah,
a good
you
one.
too. Bye.
Goodbye.
You too.
Thanks.